Look at that. We are live. What is going on, everyone? How are you all doing? I'm excited to have you here with us today for this roundtable session. And what a session this is going to be. I am super stoked to invite up all of our specialists today to join us. We've got Oliver around here somewhere. Where are you at, Oliver? There he is. What's going on, dude? How you doing?
All good, all good. Yes, it's a cold, rainy, dark December evening here in UK.
Yep. I think there is another person that is in the UK with you. Where's Michelle? Michelle, you around? There you are.
Hi guys, yeah, I'm around. I'm in central London. It has been rainy, but today there's been blue skies, which has been nice to look out at. But yeah, weather's mixed across England.
Yeah. We've also got Derek coming in here. Where are you at, Derek? There he is.
Hey everyone, I'm not based in Warsaw in Poland, but I'm actually calling in from the sunny Florida today.
Oh, so you're bringing the sun. I think Mark is the last one we're going to bring onto the stage, and Mark has a little bit of sunshine, it looks like, in his screen too. How you doing, dude?
Yeah, doing great. Up in the Bay, down in the Bay Area here. Pretty sunny, and even though I'm wearing a jacket, it's pretty warm.
You're wearing a jacket because you have AC on? Is that what's going on?
Yeah.
Excellent. Well, folks, we're here today to talk about model management in regulated environments, probably the sexiest topic of 2023 itself. We said, you know what, we could talk about fine-tuning, we could talk about LLMs, but none of that is as interesting as model management in regulated environments. So we want to get right into it. We want to talk all about it. And before we do, I know how these little roundtable sessions can go. So I want to just preface it with, I know you all are incredible and I know you all are doing amazing things, but I want to give you like 10 seconds to tell us. Don't go over the 10-second limit because I've been on these where the panels go for longer than the actual talk. So give us the 10-second snippet. Michelle, can you kick it off for us and then popcorn it over to the next person?
Christ. Michelle, lead data scientist, Lloyds Banking Group, working on an MLOps team with 9 live production models.
Boom. That was under 10 seconds. Bravo. All right, Derek, what you got?
My name is Darek. I'm a machine learning engineer at Weights & Biases. Weights & Biases is a company that delivers best tools for machine learning practitioners, which includes model management and model registries. I'm excited for this session today.
Oh, nice. All right, I like it. Mark, how about yourself?
Hi, Mark, co-founder and chief architect at Gradient. We are a large language model customization platform.
Last but not least, Oliver.
Cool. So yeah, I'm a tech lead for the science team at MCOPA. So we do various forms of loss rate forecasting for African fintech company, which does connected assets.
Super cool stuff. All right. So we've got to get into this, and I would love to know, when it comes to what we are talking about today, let's define the terms a little bit, because what do we mean when we say model management? What does that mean, just so everybody's on the same page? And what do we mean when we say regulated environments? I know there are people on here that have different spectrums of understanding of regulated environments. So what exactly does that mean? I'm going to go for the model management piece. Derek, since you threw it into your 10 seconds, I'm going to have you kick it off. What exactly is model management in your eyes?
Yeah, that's a great question. I'd be interested to hear that from the other participants as well. In my mind, model management encompasses like the processes and tools across the whole model lifecycle. So when you think about model lifecycle, you need to train a model. To train a model, you need to collect some data set. You need to choose an algorithm. Once you've trained the model, you need to save it and evaluate it. Once you're clear with evaluations, like ideally you want to push it and deploy it into production. But then once it's production, it's not the end. You need to keep monitoring. At some point, you may want to replace it with a new model, with a challenger that gets potentially better results and delivers better value for your business. So at some point, you start doing with more and more model checkpoints. And especially in regulated environments, you may come across an audit. And if an audit comes, like, you need to be able to actually tell the whole story of how this model came together, like what were the evaluation results, how you tested this for specific risks or biases. And this whole life cycle is what, in my mind, what goes model management.
I couldn't agree more. It's definitely that in a nutshell. It was very well explained. Thinking of our data science lifecycle, which is like, the 4 stages: your incubate, build, deploy, and production. So 100% agree with that.
Yeah, I think in my very specific context, the way I've been seeing is in terms of there's controls and process in place when you're essentially promoting a new retrained model. I think in our context, we have various stakeholders who consume our forecast data, and even small diffs in that forecast data can actually translate to quite large quantities of money. And having controls in place so we don't push through bad forecasts or even good forecasts involving quite big diffs is an important component of our job. So
when I think about that, I just think about the state of the model. Like, how do you manage the state of whatever is the upstream model that comes down and just has this lineage that propagates throughout the entire system?
So I'm going to try and do some fancy stuff with the way that we're set up here, because I hear people like to keep it fresh on the feed and they need those quick splices just so we can keep the visuals going. I'm going to be switching us in and out as the producer in the background while I'm asking these questions. I loved all those answers. Now we got to figure out regulated environments. I get the feeling, Oliver, you working in Africa, that's different types of regulated environments than Michelle, you working in the UK versus Mark, you're doing stuff in the US. So what are things that are specific to these environments? What do we mean by regulated? Oliver, I'd love you to kick us off with that one because I feel like that's the one I know least about.
Well, I have to point out that I'm actually probably the least experienced person in terms of financial services here. I have fairly good experience in data science, but this is my first financial services job. But I think in terms of the African market, I think it's just as regulated as it would be, say, in London and so on. I think the important processes which we care about are in terms of we have various relationships with various third parties, and essentially third parties where we essentially borrow money or we do financial reporting to and so on. And I think the important, interesting thing about financial services and the banking sector as a whole is that there's this strong requirement for essentially auditability. So it's not just enough to output a forecasted value and that's your value. You have to justify it. You have to trace the data lineage about where did you get data from, why is it that way, and so on. There's this concept about rebuttability. So it's the ability that if you do something atypical in your processes, you have to be able to justify it and so on. And I think that's a very universal thing for anybody who's had to deal with lenders and so on. I'll be curious to see about Michelle's opinion about this and has more experience from a bigger banking house and so on.
Yeah, absolutely. I've been in the data industry for about 12 years, but I spent the last 5 years in financial services with Lloyds Banking Group. So we're heavily governed by the FCH, the Financial Conduct Authority in the UK. They're very strict on wanting to understand like how ML is being used to make decisions, especially when it comes to customers' finances, because it's people's livelihoods. You can't just make willy-nilly decisions. So it is so strict. But in a good way, like because stuff is not done willy-nilly. So like for our models, we put risks on them, like risks 1 to 4, 1 being the most severe risk. Therefore, like a lot of governance is applied and we have whole risk departments to govern those level 1 models. And then ones that are less risky, they're more internal business decisions, like making sure that we're forecasting stuff okay, like in terms of our book balancing. So it's less of a risk, so that'd be more of a level 4. But anything that gets closer to a customer's livelihood or credit score, the risk goes up. So it shoots up more towards level 1. So the environment it's a lot more thorough when it comes to governance. And yes, everyone's afraid of the auditor, but when you're in financial services, you have auditors living with you. We call them like MRAV, or Model Risks and Assessment Validation Departments. And it's not that we're sitting there waiting to be audited. Like every month we present to a risk committee how our models are performing, what are the changes, why have they changed? And we're doing periodic, like massive annual reviews on them. it's a lot of documentation and governance, but I think it's the right thing to do when you're in financial services.
Is it, Michelle, just a quick follow-up on that, is it easier just to do basically something across the board with all the models, or do you specifically say, all right, well, since this one is high risk, we're going to treat it differently? Or can you just hold everything to that level of scrutiny?
It depends on the model as well, because the modeling method that you use, some of them might be very like black box, therefore you're like, right, it needs extra explanations on it to explain what's going on, or some of them might be very classic, black and white, easy to explain. You might reduce the rate. So it's the method as well as the data, and PII is hugely important. So first of all, identifiable information. So anything where you can identify who that customer is, especially with someone's bank accounts, like their age, their date of birth, their location, like their postcode, or even more sensitive like medical stuff, notes on customers' files, like that all comes into play, and that will affect what the risk score is in that model. It's the data underpinning it too.
Yeah, I think I saw before joining Weights and Biases, I worked for a consumer goods company that actually had one branch or a couple of brands that were classified as medical devices, so they were subject to some substantial regulation. And as we built system or models like across like different teams, different departments, like everyone tried to avoid medical devices because of all of the additional documentation needs that was required. What I've learned now with Weights and Biases is actually there is a way to get a lot of this documentation, for example, data lineage, model tracking, evaluations. You can get this kind of for free if you set up the right pipelines. And I think it's important, like in this context of model management, to figure out also like what is the right tooling, what are the right automations, so that you can then later on benefit from this when it comes to an audit and showcasing your documentation.
Yeah, it makes a lot of sense. All right, so moving on, I've got to ask Mark this one because I know you've been playing in the field of LLMs quite a bit. And actually, for anybody that has not seen it, Mark has a really cool in-depth dive on fine-tuning LLMs. It's one of the most popular videos on the MLOps community YouTube channel right now. And we'll link to that in the chat so you can check it out later. But for this context, how does model management differ in the context of LLMs versus traditional machine learning?
Yeah, I think the main thing that governs all of that, in my opinion, is just how large the data sets are. So unlike in traditional machine learning, where you can manage your models fairly easily, roll them back, roll them forward, update them, that's just not really easy to do with LLMs. Like, you don't know what's going to happen with the model once you update it with new data. It requires, tens of thousands, maybe hundreds of thousands of dollars just to do like a small experiment and update the model. And being able to control that entire process is quite a bit harder. So there's just a lot of downstream implications for getting a little bit more nuanced, a little bit smarter about what you do when you have to manage these models.
I have a question. And this is related to what you said about LLMs and the fact like training an LLM requires like it costs a lot of money. When we need to like update the data set for training a traditional ML model, like say an XGBoost or some tabular model, like it's fairly easy and cheap to just change something on the data front, let's say remove certain private data and then retrain that model. For LLMs, I know there's been some research around like model unlearning or like fine-tuning a model to forget some information. Have you come across that? Is that still at the research level? Has this been propagated into practice, specifically in regulated environments?
Yeah, I actually think particularly for finance, right? People want to know, is the model updated with the latest SEC filings? If you have like a downstream financial analyst case, my team, we're always researching these type of things. In particular, like what's the correct mixture of data so that you can unlearn and allow it to unlearn things that aren't necessary and actually maintain its ability for capabilities that you need further down the road too, right? Not destroying its math capabilities just because you want to update the latest quarter of financial reports to some financial model.
I'm now put on the spot. I was actually going to mention about like in the bank using MLMs. Obviously, they're hugely valuable and important in the industry, but we have to be so careful. Like, we can't use ChatGPT internally, because if we go and use it to be like, hey, want to write up a risk report for X, Y, and Z, that data is leaving the bank and that exposes it. And it's like a massive security risk. So LLMs are massively valuable, but finding some way of being able to firewall them, that data doesn't leave the organization and it's super protected, is like the value that I think a lot of people need with LLMs. But it's the risk and the safety of how that data is getting out when you're using them.
Yeah, that's such a great point. And it also feels like, considering we don't know that much about what can come out, the output is almost like a crapshoot. And sometimes, depending on our prompts, we're throwing spaghetti at the wall. And I'm sure a lot of you saw that if you say, hey, repeat the word poem infinitely forever, and then all of a sudden it spits out PII, and you're like, whoa, that's not what I wanted at all. So even if it was inside that walled garden, you really don't know what the output is. You can't be super, super clear on what it's going to be. And that can be a huge security risk too, at the end of the day, I can imagine. And especially when you're in these regulated fields where you can't let that kind of stuff happen. There's no excuse for it happening.
Couldn't agree more.
So we're going to keep it cruising. And I'm going to ask you, Oliver, I think we'll change gears a little bit from the LLM space, and we'll go into this one on how you handle the feedback loop between stakeholders and modeling / reporting process, and what particular challenges are special to the business and the markets that you're operating in. Again, because I'm intrigued. I am fascinated by what you're doing here. So maybe you want to give us a little more context on how you look at that and what things you're doing.
Yeah, so I think one of the main outputs we work on is actually loss forecasting. So essentially it's a loss on our loan book. And we have, as I mentioned, quite big changes. It's quite a small change to the forecast have quite big financial implications. So we need like a fairly good feedback loop with the stakeholders. Essentially, it's not just enough for us to publish a forecast and then say, this is our forecast. There's often an interplay between the two. So we essentially have to, it's somewhat unsexy, but we essentially have to do fairly manual validation checks. Historically, we had a manual retraining process, and that introduced a fair bit of manual pain. Essentially, there's a long exchange between the stakeholders themselves. But we moved on, and now we have automated processes. And for example, we use race and biases as our process for essentially automatically retraining. And then we have various validation checks. And then, but however, what we do still do is we still have a human in the loop. So essentially, once we pass certain validation checks, we have a QA step, where we use model registries and so on to essentially manually promote the models. This way, it kind of ensures that we have this manual step where we can double check the data and ensure that it's actually valid before we push it to the various stakeholders. I think one of the interesting things about our business is that because we work in African models in markets, essentially it's a very volatile market. There's all sorts of macroeconomical factors going on. There's various currency exchange problems and so on, which means that the performance on our loan book can fluctuate quite substantially. In addition, it's a very competitive landscape. There's other competitors out there with very aggressive pricing. And also, our business has grown a lot compared to a few years ago. We have a much bigger loan book, a much more diverse set of customers, a much more diverse set of products. And that makes it quite hard for us to differentiate between, say, what is a data drift issue due to, say, bad upstream data models, for example, maybe a bug that's been introduced somewhere else, and differentiate between actual genuine shifts in our loan book forecasts and so on. And I think that's when we really need to step in and actually have a human in the loop. I think the trouble is that we often have to justify and rationalize those kind of forecasts before we can push them out to the stakeholders, before we push it to the reporting and so on. So part of our job, which we're increasingly automating, trying to avoid as much ad hoc EDA work as possible, is to kind of justify to stakeholders, like, look, this shift is actually a genuine shift due to changes in customer performance or due to macroeconomic factors. And so I think that's an interesting challenge. We work in a very volatile market. We have very fussy stakeholders who won't just accept our forecasts at face value. And so we do have to have these manual processes in place.
We have the same, Oliver, if it makes you feel any better. Like for every live model that we have, we actually split the model ownership into two parts. We've got like data model owners, which are like the person owning the technical code base. And then we've got like the business model owners, which are the stakeholders. They are responsible for checking the outputs and being up to date with what the model is doing and to be really happy with how they're using it. And if they're not using it, it gets turned off and they don't get it anymore. So it's putting the ownership between two people, so it's not just on the dev team. It's like the business you're using this as a tool. You need to be responsible.
As a business, we're not quite large enough to have that kind of division of labor, but I have heard that system being used elsewhere, for example, in large energy companies, where essentially you have a dev team whose focus is primarily around about, say, improving forecast quality and outputting forecasts, and then a second team which is involved in validating and essentially building the story around those forecasts and so on. That way, there's almost like a separation of powers and division of labor, so that the two teams essentially check and balance each other.
Yeah, no, I'm glad you've heard of it too. I thought it was extra admin, but I'm like, actually, this kind of works.
Yeah,
it's even this is back on the stakeholders.
I think if you have a large enough organization to do that, then it's great.
So the other piece that I would love to dig into with that, what you're talking about is that whole data quality piece and how that plays into the model management. I would love if you dig in, and I appreciate you painting the picture for us. Like, it's hard to tell sometimes if we're dealing with data quality issues or if we're dealing with real life changing issues, and it just means like life has changed or the society has changed, whatever it is, external factors have changed, or if it's internal to our data. Are there other ways that you are attacking that problem?
So essentially, our actual automated tech stack is actually relatively unsophisticated at the moment. We have various automated thresholds, which essentially which are analytically derived from, which essentially, say, if we compare forecasts from a challenger model or the current model, or compare forecasts one day to another day, if they exceed a certain threshold and certain key dimensions, then they're flagged up for validation. But what we have done as essentially a proof of concept, and it's really the next step of this, to do some usual actual feature drift analysis using standard tools such as, Y-logs, evidently, Great Expectations, to try and actually have more formalized processes for assessing feature drift. I think, though, there's two separate kind of problems. There's feature drift in the sense that your feature set has changed, and there's feature drift in the sense that your data model is broken. Like, say, for example, if you say dupes have been introduced somewhere in the data set, so you have degraded data. We have, there's also various formalized processes for doing that. We use DBT, for example, in the upstream data stack, and that comes with a whole testing suite for testing those data models, and we have alerting set up for that. The other problem is data drift, where there's not a clear breakage of the data model, and that's the harder problem to solve.
Makes a lot of sense. And I'm guessing, because I'm reading something right now, and I'm remembering back in the day in 2020 when COVID happened, how much data shakeup there was in that regard, and how everyone's dashboards kind of went out of whack and what happened there. So I may have just given a few people PTSD. If I did, I'm sorry about it. Did not mean to in any regard. So let's keep it cruising though. And Derek, I'm going to kick one off to you. And I'm wondering about, like, as you're looking at regulatory needs and you're seeing benefits when you're working with customers of weights and biases, what other pieces are you seeing people gaining by adopting these best practices, and maybe like what some easy wins are for people right now, just to go, oh, hey, you know what? I could do that today, and it could be a really easy win for me to start having a bit more security in and be able to sleep easy at night.
Yeah. Okay. So as you start if I go back to like the beginning of the model management lifecycle, let's say you start training a new model, and typically people do that. Like most of our users, the practitioners that we know do it in code. They might be using PyTorch, they might be using TensorFlow or Keras or Hugging Face Trainer. So typically they start with a piece of code, and what we recommend is you add a couple of lines of code into that training script to log data, to log results into weights and biases. And what you get as a benefit of that is you start, like getting some reproducibility. You start tracking your experiments in a system of record, and that gives you that already gives you like the first layer of documentation. Once you're ready to move on to the next stage, and you log your models into our model registry, you get like the next level of benefits and documentation. You are able now to track for this specific model checkpoint, what is the status, what is the lifecycle status of that model. Is it currently in staging? Is it in production? Is it in testing? And then you're able to backtrack, like, okay, how was this model trained? What data set was used for that model? If I need to reproduce that run, then I know like what's the compute that it was trained on, what was the GPU, and all of that stuff that is important for reproducibility. What you can do then on top of it is you can build a bunch of automations, but at the same time keeping human in the loop. So maybe you want to like kick off your evaluations automatically, and then like send those evaluations in a nice report to your business stakeholders so that they can take a look and give the approval to move forward with the model. And a lot of companies, a lot of customers do this for regulatory reasons. But I would say even more customers like do the same kind of things to get better value, to get better models, to increase their iteration cycle, get more velocity in their machine learning experiments, and also to improve teams' productivity. So, I've seen like multiple cases, there's a team of people, maybe like one key engineer working on a model, and then that person leaves the company. Like, how do you continue working on that project? Like, in my previous experience, it was very hard. Like often people like just crashed everything and started from zero. But like with weights and biases, like you are able to backtrack exactly, okay, what was the last experiment? What was the set of experiments that was done on this project? What was the data set used? And you kind of like very fluently can continue with the work. And that helps internally with productivity, but that also helps like if you get an auditor and an auditor asks you, okay, how was this model trained? What data set was used for that model?
Yeah, to interject there, one of the primary uses we use weights and biases, use it as almost like a de facto feature store. So we use weights and biases blob. We also use Azure blob as well to essentially log the feature sets which are used when training, the feature sets used in forecasting. That's where we store the models. And it gives us a very, very clear lineage of what was used to do what in a kind of almost like a permanent record of where it was. So.
Oh, wow. Yeah, I remember talking to a guy and he was talking and telling me about how someone left the job that he was working at and it took him 6 months to just put together all the breadcrumbs and figure out what was actually going on with one model. One model for 6 months. It was like so painful for him. And so, Michelle, I know you got something to ask through here. Feel free to throw it in.
Yeah, it was about the lineage and stuff. So, do you know when it comes to models and like using them, do people pickle models or let them build live? Because they both have, well, if you pickle them, you've got a model registry that you can go back over and look at, but then you run the risk of not having the latest data in an old model that might not be relevant to the most current thing. It'd just be interesting to know what people do with regards to that and how flexible they do be.
So from our point of view, we pickle primarily for practical reasons in the sense that it takes around 2 days for us to train the model. So you can't do a daily train and forecast cycle. I'm curious, I'm guessing from an LLM point of view, then that problem is even more severe, that you must have some kind of like permanent state for models.
Yeah, I think everything goes out the door when you work with LLMs because you can't even load an eighth of the shard of a model or with LLMs. If you shard the model, if you have it in floating point 16 versus BF float on what hardware, those things will all prevent you from having reproducibility. So, Hugging Face has a great safe tensors format we actually have some custom serialization elements within our models too as well, to have inter exchange protocol with respect to how we can do fast reads, fast writes, checkpoint restarts and resumptions. So if anything, to jump back on the weights and biases aspect, we're a user of weights and biases, mostly because it's the easiest thing to, like, out of the box, it came with almost everything we needed. And when you are training, like, we do some like pretty beefy near foundational model training. And when you have 48 A100s and you need to know whether the checkpoint did an auto resumption in the framework we use, it's just having to have like looking at that loss curve and just being able to immediately visualize and see if something went wrong. And then just having to not build alerting, just having it send my message to Slack and know that, hey, we got to restart, a certain training job and we need to continue on with all our GPUs. Having that all integrated into one is useful.
Yes. So keeping on this train, I want to take some questions from the audience, and there is an LLM related one. So Mark, I'm going to keep you on the stage there. What open source LLMs have speakers considered and or implemented for entirely private and secure deployments?
So a lot of people, you leverage mostly the Llama models, not because they're the absolute best at every point in time, but because they have multiple flavors and sizes, and then a little bit of reproducibility, and more of the people in the open source use them. And, my belief is, as well as probably most people, it's all about the data. Like, it's your private data combined with the foundational model. That's the entire point of these foundational models. So most people use Llama, and then for we're seeing a lot more interest in multimodal models. So a few folks have tried to deploy like the UFU model from Adept, or some of the open source reproductions of the Llama model.
Yep. Yeah, the Llama one's awesome. Also, I've been seeing a lot of people enjoying the Mistral model. I imagine you too, just because it has not been censored at all, and so it gives you a little bit more flexibility in that regard. But I'm curious, Oliver or Michelle, have you played around with any?
In financial services, it's like Fort Knox. There's no way you'll get it in. The closest thing I got to see to LLMs like live in the bank was like my data director. He got access to some version of ChatGPT on his Teams, and he was like messing around with the LLMs to be like, "Hey, fix my code, fix this." And it was such a lockdown environment. But I was like, it's progress, but like so far removed from using it like within financial services.
I use it sometimes to help me fix code. But I think in terms of actually deploying models, I think one of the important factors is there's often quite strong onus on us for explainability. I know, for example, we also do credit scoring. For example, in credit scoring, one of the big problems, you need to be essentially able to make it very clear what feature induces change in the credit score. That's very straightforward. I mean, I think much credit scoring even nowadays is actually done with very basic logistic regression models, for example, for that reason. And similarly, I think that onus and explainability means that maybe unfairly, LLMs or any kind of neural net is just a bit too far away from too black box, too scary for financial services, for the auditors.
Yeah, I mean, it's kind of for a good reason, right? I can understand that viewpoint 100%. And speaking of explainability, there's a great question that came through the chat for Michelle about explainability. How much explainability do your teams need to build into their modeling? Do you all use specialized tooling for it, or is it a lot of manual ad hoc processes?
So it's hugely important for us. Remember, I was saying about how we split the responsibilities between a data model owner and a business model owner. The business want to be able to understand what features are going into the model so that in their heads, they're able to tell the story, and it backs up the knowledge that they have as subject matter experts. So if I build a forecasting model and I'm saying, hey, depending on how much customers do in these months and what their transactions are and what the behaviors are in these products and what the interest rates is at these time, this is what the value is going to forecast as. they relate more to that, and they're more likely to take responsibility of that model and sign up to using it and owning it. So it has to coincide with the logic that they recognize and the reality that they know and see within the business, if that makes sense. So it's not just like when people say explainability and they're like pip install SHAP and stick SHAP on a black box model. It's not that. It's like bring them on the journey, like make them understand what the data is, what the features are. Because sometimes actually our stakeholders are quite like, I find them quite smart. Like some of them are building models in Excel because that's their toolkit, but they know how things work and the formulas and the calculations. So they're little like mini robots in their heads. They may not be like coding and programming and heavy lifting in data, but their knowledge of the business is unreal. So it's tapping into that.
You said that a bit surprisingly, like our stakeholders are smart, surprisingly enough.
Different skill sets, but super smart, different skill sets. Like they might not be able to code it in Python, but they can dance circles around you in terms of business knowledge. And if you don't know it, and if you haven't dealt with it properly in the code, you're going to get wiped out.
I think just to add to that on our side, I mean, we output forecasts, but those forecasts are added to a reporting data warehouse, which is where essentially it's joined onto other useful business reporting metrics and information about the loans, and then surfaced through Looker, for example, and that enables the stakeholders to essentially build their own story, and they do that quite successfully by themselves.
And Derek, I'm wondering about so like what Michelle was saying, how take people on a journey with you. It feels like that kind of goes in line with what you were mentioning earlier. And how do you look at it and bringing people along on that journey and unifying those two fields or those two camps?
Yeah. I think that's a super important point, and I think that's like one of the key ingredients to managing successful machine learning projects is to work very closely with the business stakeholders that are ultimately going to be using these models. And, I like before joining Weights and Biases, like I was often working in business teams, like on machine learning projects. And typically the way I would communicate with the business is, do a prototype in a Jupyter notebook. Then my business partners didn't use Jupyter notebook. So I would then export that to an HTML file, and I would attach that HTML file to an email and share it with them. And they would like, look, hey, this is like the predictions. These are my targets. Like, does it make sense or not? And we would have a conversation around that. And it worked pretty well, but it was super inefficient. Like what I would do today is I would just link a Weights and Biases report where they can, have the same type of thing, but it's linked to the exact experiments and model checkpoints, and kind of it's using the common system of record. So definitely, like I think that's a great point, and hopefully our tools are allowed to do this with much better productivity.
I was gonna say I might take the opposite side of things actually, just because it's fun to do that. But with LLMs, a lot like my argument on explainability is like anything past regression, we're still trying to proxy for linear explainability, right? Explainability oftentimes is just like, can you express it as a vector? Whereas like for language models, you're actually pushing it so far past like those tasks that you have like highly composable tasks, and we needed these like extremely deep and huge models to be able to do them. A lot of the literature now is actually going back and trying to bolt on explainability too. So like model composability, figuring out the sparse networks that are activated during certain request patterns, and then like defining them to concepts like those. If anything, that's like, in my opinion, like the next level of abstraction for what explainability might look like for us in the future. Because like it's more, in my opinion, trying to get an LLM to explain is like getting a doctor to explain to you how they came up with your diagnosis. It's like a very complex path rather than like getting like linear weights or a linear vector of weights.
I was going to ask a follow-up question there. So if you were in a situation, how would you try and encourage trust in people who are consuming the outputs? Do you have standard ways in which you can kind of validate that these outputs are good and reliable?
Yeah. I think that's why evals are so important, and which is a something that the community, the open source research is trying to do more and more. But like, you can one aspect that's interesting about LLMs is they can express their confidence in their predictions if you prompt them to do that, and they can actually go in and they act almost as like a oracle to go inside of the compressed knowledge that they have to express that and actually they can be very transparent about how they came across their predictions too as well. So I just think it's going to be an entirely different approach to it, which is pretty exciting actually, in my opinion, because when I prompt an LLM and I worked on prompt engineering, I'm like, it's like teaching an 8-year-old. Like, you have to do very specific, extreme language. Sure. And then when you express it, then you actually get like very consistent output. So even the way that we train models, like I build curriculums of corpuses to be like, you got to learn math first, then you got to learn, the next step of it, and then you can learn, how to analyze a balance sheet.
I would challenge though, like it's actually quite similar. Like at the end of the day, like I feel like even like with an XGBoost model, you only get, like little value, I would say, from like putting sharp on top of it. I think like it's really like looking at the error cases and having like exactly what you said, Mark, like a good evaluation, understanding where the model might be making errors and trying to figure out if there are any trends and patterns around like the failure points of the model. And I feel like that part of the process is similar for like, let's call it traditional ML and LLMs. Like you need to have a good evaluation. You need to understand like where is your model like having reasonable performance, and like what's your threshold of acceptable performance. Like you need to understand the error cases and kind of go into this iterative cycle of improvement around it, ideally bringing the business stakeholders along in that process.
Well, it almost feels like when you're able to bring the business stakeholders along in that process, and as Michelle was saying, there's different understandings of the business, and you could probably get to debugging things a lot faster if you have someone who's the expert and you can take them on that journey. I'm wondering if Michelle or Oliver, you felt that is a consequence or a benefit that you've seen because of the way that you've set things up?
I feel like so with us, we have a lot of we need to reprogram, but UI is built in React, where if you look at the dashboard for a specific model, it'll tell you what version of the data it used. It'll tell you what version of the model was used, because we do a lot of releases and we release like it's very CI/CD, release often and frequently, hence being an MLOps team. But we use that quite a lot, and all that tracking is there and the stakeholders can see it. And a lot of times they pulled us up being like, hey, whatever you've done with the model between September and November, it's completely screwed the forecast. Can you go back and look at it? And I'm not being funny, but they've actually generated like really good investigative work for us, because we're like, oh yeah, we changed the model massively. Like that's where the forecasts are completely off. We didn't pick up on it because we're not the end user. So I think enabling the stakeholder with the tools to like kind of not poke at your work, but just find the data lineage and the model like registry to like specifically go, hey, it's these key points have created a massive difference, because then we know where to go and look, but they don't know where to go and point to if you don't give them the little information.
Yeah, I mean, I would second that. I think in our context, we're data scientists, machine learning engineers. We are very good at solving data science, machine learning problems, and we can monitor that and so on. What's really useful though is when you do communicate with stakeholders and they may identify certain changes in data, changes in the forecast, and they're able to construct and understand the story better than us because they have a better understanding of what's happening on the ground. So having this process where they're able to consume this forecast and then correlate it with other data and so on enables them to do that investigative work for us in a way, and then that enables a feedback process.
Sure.
So I think having those frameworks in place is very, very valuable.
So we've got a question from Harshil coming through in the chat, and this is a two-parter. And I'm going to lob it up there, see who wants to grab it. Feel free to jump in, whoever, or I can pick on some people. Number one on this, and we'll start with this one. How do you communicate model-related insights, limitations, and performance metrics to non-technical stakeholders? Michelle, you were kind of touching on that. But
Do you really want to know mine?
yeah,
So,
but there's a little bit more to this. So it's not only
Sure.
to the stakeholders like the business side of things or the subject matter experts, but also the regulation bodies or senior management.
I can give you an example of like how I'm told to explain stuff. I very much try to tie it to a story. So someone asked me recently, explain a statistical distribution to your grandmother. Now, my grandmother is a little old. She's deceased now, but she was a little old farmer's wife, so she knew the farm very, very well. And I was like, "Well, grandmother, think of bottles of milk." I was trying to explain a Poisson distribution and how, like, at the start, the milk is really, really, really fresh for the first couple of days. But after like 7 days, it's very unlikely anything's going to be fresh. So I was trying to explain it in those terms. And ever since then, I kind of do the same with the business. So I kind of be like, oh, if a customer went to open up an account and we went to offer them a credit card and we were giving them metrics and we happened to pay them, like we gave them more credit because of their gender, like that's not okay in our modeling. So trying to give small snippet stories where they can envision something of a person doing something tends to resonate a lot more than going into, hey, this is the formula, how you calculate an F1 score is going to bore them to tears.
I don't have any good stories about that, about trying to explain statistical distributions, unfortunately. But I think one thing which definitely does, in a way, MAE scores, position scores, whatever, are valuable to us, and in a way, is in some ways not even worth trying to communicate those. The way we try and do it essentially is really boil it down to the KPIs which they actually care about. And I think those two, the two things we care about, they care about are forecasts and the accuracy of those forecasts in a way which is quantifiable within the context of the forecast. So, for example, we have various ways when we run essentially back tests to try and assess how accurate our forecasts were, to try and build some broad approximation to prediction interval on the forecast and try and ascertain how accurate we were in the past for these forecasts. That's kind of, so that way we try and boil it down to the KPIs and the metrics that they care about, and not worry about the data science metrics, which may be important and informative for us, but not necessarily for the stakeholders who, are not stupid at all by a long shot, but don't know and don't necessarily care about those metrics.
Yeah, from my standpoint, I came from a traditional machine learning background as well, but with the customers that we have to explain, model performance or, show them the value of what this model can do and the risks. Evals, again, my evals these days are just so direct to what the value is to the customer that they almost are never interested in any sort of statistical measures. They're like, hey, how many times does it get this Excel formula right? How many times, can it automate all of our text extraction in our document processing? And then one number out, if it reaches their metric or benchmark or not, that's the only thing that they actually care about. And then if they have questions on the risks, I can almost do it live where they want to prompt the model and see, what's going on. And then we can do a simulation live on how to simulate their exact use case for that.
Are you focusing on creating custom evals for everybody that you're dealing with?
In my opinion, it's really hard to have any sort of evals as a service work in a way that can deliver really, really explainable value to a customer. And I think that's part of the journey. Like, at least where we are in the entire AI and LLM space, the bangers are in the custom evals. Like, all the other ones are kind of proxies. But when you come out with a really nice custom eval for a particular customer, it almost is like, the whole analogy of a picture is worth 1,000 words. That's about all you need if you can just hit the nail on the head right there.
Yeah, that makes 100% sense, because you get to show people this is what it's doing and this is where it's messing up, or this is how many times it's doing it right and how many times it's doing it wrong. How do you feel about that? So, like, is that good enough for you? If it is, let's ship it. If it's not, let's go back to the drawing board.
Yeah, totally.
So part 2 of this two-parter that I'm going to bring up, Harshil has got the other piece of it is, how do you ensure effective collaboration and alignment between data science teams and other departments such as legal, compliance, risk management, all those fun teams that everyone loves working with, I can imagine?
You don't make the data scientists do the governance work, in my view. So like my team, we have like 20 data scientists, but we have 4 managers that will be business facing and will do all the stakeholder meetings, management. They'll be responsible for presenting a little bit of the modeling outputs, but they won't be expected to know what the models are, what's under the hood. That's what the data scientists do. I find sometimes you need specific stakeholder management governance people, because that work isn't super technical. But again, depends on the organization size. I'm blessed at the moment to try to do any governance, and I'm knee deep in governance models.
I think I can come in from a smaller organization and slightly different property designer organization, in the sense that I think what we do is we more heavily matrix. So the idea is we have product teams, and those product teams are a mixture of data scientists, engineers, product owners. And we're actually, in this particular case, although we don't have any matrixing with legal or finance, but we do have heavy involvement with those teams. And that way we're able to collaborate and get the information we need. In fact, just the other week, for some, had some fairly extensive meetings with some key stakeholders in finance around some common projects we're doing. And that way, by having this matrixing approach, where you essentially move multiple discipline people into one team, then enables the mixing of knowledge and so on. It does come with its problems, because you need to have relative isolation, but I think for a smaller organization which is more product driven, then it maybe works better.
So if I'm understanding this correctly, from your side, Oliver, you're saying you embed the different people into the team and then they're working closely together. But from Michelle's side, it's a little bit more like there's somebody that is the data science API almost for the legal compliance, and they're the wall between them, or the cushion per se.
I love that. The API is class.
So just tell legal and compliance, send it over to the human API and see if you get a response there. That is how you could go about it. And I guess, so Michelle, I can tell that you're very stoked in the way that you have formed it. Oliver, do you feel like you should shoot for going towards something like Michelle has, or are you also equally as stoked, just in a different way, on the way that you have organized it?
I believe it's almost a cultural and an artifact of the size of the organization and the age of the organization. Essentially, we in MKP are kind of very broadly a late stage startup, so the organization is much smaller. We have many more products on the go. So we just simply don't have the resources for a big centralized data science function, which I believe the likes of Floyd and so on would do. And so essentially, I think it's almost a symptom of that difference. I think very much there is it's almost a cultural little war. I think some people want to go for this very matrix product based thinking about how we operate teams and do DevOps, versus a more traditional thing where essentially you would have like an analytics department or a data science department, which would be centralized, and essentially would then be where there would be essentially almost a request for services coming from other departments. If I'm honest, I prefer the product-based matrix approach. I think it gets you closer to the problem and makes you better understand the problem. But at the same problem, it does mean that you are relatively isolated as a data scientist, if you're a data scientist, or an engineer if there's not a large team. And also it does mean there's much more of a bleed-in of roles and so on, which means that you may maybe not be so focused specifically on data science tasks. I think it comes back to the point where essentially, where it seems like there's 2 teams involved in the forecasting function at Lloyd's, where essentially one is involved in one component, the other is involved in another component. In my situation, we do all of it all at once. So
yeah, it is an interesting thought to see how you are able to get that expertise, and you are, if you have it at the forefront of your mind, I imagine you're going to be looking at things a bit different. But then again, where can you add the most value, right? And if you're spending your time learning about regulation and all that, as opposed to just having someone tell you, no, you can't do that, and you don't ask questions, you're just like, okay, sweet, I won't do that then. Which one? It's a funny way of looking at the organizational piece and deciding which one's for you and what you find more valuable. Pros and cons always. It's all those trade-offs. So, folks, I think our time here is coming to an end. As much as I love hanging out with you all, I think that this is about it. I want to give a huge thank you to all of you that have come along on this journey with us and have been on the panel, have spoken, and then also everyone that has been asking questions in the chat. I loved it. I really appreciate everyone's voice in this. And of course, we got to say a huge thank you to Weights and Biases for helping put this on. That is incredible. And if anybody needs anything, I think Derek's DMs are open, right?
For sure. Please feel free to reach out.
There we go. We will see you all later. Have a great night, day, wherever you are in the world. And thanks again, everyone, for joining. Take care.
Hey, I'm Vishnu. I'm a data scientist at First Hand, and I definitely think that you should subscribe to the MLOps Coffee Sessions podcast. It's the best podcast out there to stay on top of what MLOps actually is, to talk to the true thought leaders in the space. And oh, by the way, Dimitrios is absolutely hilarious. What a weird guy. You should definitely subscribe to the podcast.